Hello guys, welcome to Spatial. I'm Javad. In this channel, I post tutorials on ArcGIS Desktop, Google Earth, AutoCAD, and other spatial tools. So if you don't want to miss these videos, please subscribe to the channel and hit the bell icon. This is the first video I'm making and I'll give you some basic information about GIS. Let's get right into it. The first question that rises, speaking of GIS, is what is it? Well, this has not an easy answer. GIS stands for Geographic Information Systems. The first word, geographic or geospatial, is key in understanding GIS. GIS tells us the location of things on the Earth. It allows the geographic features in real-world locations to be digitally represented and stored in a database so that they can be abstractly presented in a map form or analog form, and can also be worked with and manipulated to address some problem. The second word, information. We have two kinds of data in GIS. Geographic data and descriptive or attribute data that refers to the geographic data. For example, we have the location of schools in a city. These are geographic data. But the names of the schools, their area, number of students, or number of teachers, and you name it, are all attribute data. We know that there are some differences between data and information. Data is raw and without meaning in itself. If we process data, it becomes information. Information has context and carries a logical meaning. In GIS, we process and analyze the data. It becomes information, so we know what is where and when. Thus, in addition to space, we can have another dimension and variant, and that is time. Therefore, GIS gives us information about what is where and when. The third word, systems or science or studies. Systems refers to the technologies for management of the geographic or geospatial information. Science refers to the concepts and theories behind this technology, and also conceptual issues of representing data and processes. And studies pertain social, legal, and ethical issues associated with GIS as systems and science. But what is the definition of GIS? There are many definitions out there, all of which I find this one more comprehensive. A system of integrated computer-based tools for end-to-end processing, capture, storage, retrieval, analysis, and display of data using a location on the Earth's surface for interrelation in support of operations management, decision-making, and science. What can we understand from this definition? We can understand that GIS is a set of integrated tools for spatial analysis. GIS encompasses end-to-end processing of data, capture, storage, retrieval, analysis, modification, and display. And here, end-to-end means from the very beginning to the very end. GIS uses explicit location on the Earth's surface to relate data. GIS aims at decision support as well as ongoing operations and scientific inquiry. If I make it simple, GIS is a map with a database behind it, a virtual representation of the real world and its infrastructure. A consistent as-built of the real world, natural and man-made, which is queried to support ongoing operations, and summarized to support strategic decision-making and policy formulation, and analyzed to support scientific inquiry. Here, we see common uses of GIS in different fields. GIS is used in a wide variety of fields, from urban issues, environmental sciences, political sciences, civil engineering, business, education administration, real estate, to healthcare. For instance, In urban planning, GIS is used to locate subway stations so that 90% of the population can access them with a maximum 5 minutes walk. Or a meteorologist studies the paths of hurricanes to predict where and when they might occur in the future. Another question that rises is, how does GIS system work? Imagine this is the GIS system. Just like any other system, it has some input. It carries out process on the input, and it gives us some output. The input of GIS system is data and query. Data includes geospatial data and attribute data. But what is query? One of the defining characteristics of GIS is the ability to ask questions and get answers in a spatial context. These questions or queries are requests for information that are posed in a specific fashion. For example, who owns the land parcel on the corner? How far is it between two places? Where is land zoned for industrial use? So the input of GIS system is the data and queries or questions that we enter into the system. These input make up geographic database. The database is analyzed or transformed if needed. Then the result is displayed and exported as output. For example, we have a river and the buildings along it as input. We want to specify and export buildings located within 100 meters of the river. We enter the query into the system as input. The system processes the database and specifies and displays them, and then we can export the map as output. The database can also be exported as output without any analysis or transformation. As you can see here, from geographic database, an arrow is drawn directly to output. You may ask, how is data stored in a database? In order to respond to this question, you'd better get familiar with the concept of layer. Layer is a means of organizing contents of a map. Data is organized with layers representing a common feature. Layers are comprised of two data types. Spatial data, which describes the location, and attribute data, specifying what, how, and when. Here we have three layers: streets layer, buildings layer, and vegetation layer. These layers are integrated using explicit locations on the Earth's surface. If these layers don't contain geospatial data, cannot relate to each other. Thus, the geographic location is the organizing principle here. Layers may be presented in two ways: in vector format as points, lines, and polygons, or in raster or image format as pixels. I will elaborate differences between vector and raster formats in the next video, so if you don't want to miss it, make sure you have subscribed to the channel. If you found this video useful, please hit the like button. Till the next video, bye.